We're going to do some of the problems here on page 9 and 10, and I think that's it. That's what the agenda is saying. So it should be pretty quick. All right, so I have this multiple choice question on number 16. In which circuit above are the ammeter and the voltmeter connected properly to read the current and voltage? So we know that the ammeters have to be in series, voltmeters have to be in parallel, in other words, across the resistor. So it looks like this is the one that's correct. In here you have an ammeter that's connected in parallel to the battery. That's not going to measure current. Here you have voltmeter should not be in series, and here the voltmeter cannot be in series. And also the ammeter cannot be in parallel. So the answer is just A. Okay. In the circuit number 17, what are the correct reading of voltmeters V1 and V2? Okay. We're going to do more of this when we do parallel circuits. That's coming early next week. But if you look at this point here, this is the negative side of the battery. Okay. All these points here are connected directly to the negative. And these points here are also connected to the negative. All the points, this is the positive, all the points here are connected to the positive side, which means the voltage, if the voltage between this plus and minus is 6, the voltage between this point and this point is also 6. And between this point up here and this point up down there is also 6. And we'll do more of this when we do parallel circuits. Okay, number 18, we're given a volts versus voltage versus current graph, and we're trying to figure out the resistance. Okay, well, if we look at this, V equals IR, right? And that's kind of like the Y equals MX plus B. So it looks like R is the slope of this line here. So if you want to figure out the slope here, I think we can go up 50 and over 2. So that should be 25. Okay, now we're going to talk about something called the internal resistance of the battery. So every battery has an internal resistance. Okay. An ideal battery is a battery with no internal resistance. So if you want to find the current going through this circuit here, so the voltage drop between points A and B is going to be equal to the voltage provided by the battery. This weird looking E is basically the electromotive force, which is also can be called the voltage, minus whatever voltage was used up by this internal resistor. And according to V equals IR, that's just going to be the R of this resistance times the current. Now, what you actually get in is 34. You're not getting the whole 43 because this internal resistance kind of like uses some of that 34. Equals 43 minus the internal resistance 8 times I. So if we do the math here, what do we get? We get 3, and so that's 9 over 8. So the current is 9/8 of an amp. Okay. Number 20, find the resistance of an electric light bulb if there is a current of 0.8 amps when the potential difference is just another word for voltage. Across the light bulb is 120. So we're going to do V is IR. So we say 120 for voltage, current is 0.8, and we can figure out the R. And the R should be 150 ohms. This one here is the same formula. And we're going to just say 8.75 for the current, 13.7 for the resistance, and our answer should be about 120 volts. Okay, this one is asking for current. We use the same formula. So your voltage is 240 equals I times 38. And if you divide, you should get a current of 6.32. And we are at the last one. Again, Ohm's law, V equals IR. The voltage is 9 volts. The current is 25 milliamps, so make sure you change that to amps times R. And if you divide here, you should get 360 ohms. So your R is 360 ohms. And I'm done.